On March 23, 2012, NASA Mission Control informed the crew of the International Space Station via radio that a lot of micrometeoroids would collide with the ISS 6 minutes later. This radio message caused chaos among the astronauts, who had so little time that they couldn't even change the direction of the space station during this period. But the question is, in the part of space where the ISS is located, there are countless micrometeoroids. So how does the International Space Station, or ISS, ultimately survive these meteoroids? How does it manage to change the direction of the ISS, which weighs as much as 380 cars, without fuel and without any external help? How is module taken into space, and how is contact made with the ISS when it is on the other side of the Earth's surface? These questions are addressed once again in ZEM-TV videos. Welcome, viewers! The International Space Station, ISS, was built at a cost of $50 billion, or 2375 billion rupees. It is a unique home for humans in the history of exploration. Hundreds of high-tech parts have been used to make it. There are 16 pressurized modules in it, which includes separate modules for living and sleeping, observation deck, and 6 science labs. All of these modules are interconnected through airtight tunnels. Many spots in the ISS are still vacant. Some are reserved for parking extra capsules, while others have lifeboats permanently parked for emergencies, ensuring astronauts' safety until help arrives. The International Space Station is the most ambitious project ever undertaken. It is the largest space station, as big as a football field. Even though it is 400 kilometers away from the Earth, its size can be seen from the ground with binoculars. To estimate its size, imagine if you were to compare it with a real-life object. Consider that it is as spread out as the base of the Burj Khalifa. The International Space Station is even bigger than that. The total weight of the ISS is 460,000 kilograms, which is as much as 380 cars or 25 passenger buses. But the question is, how did such a heavy and large ISS go into space? The ISS began with just 2 modules, both of which were connected to each other in space. One module was built by America, while the other was built by Russia. After the collapse of the Soviet Union in 1992, America and Russia collaborated, and the 2 superpowers worked together to establish a presence in space. They sent a module named Zarya into space, and then America launched its unit behind it. Traveling at a speed of 27,000 kilometers per hour, the unit chased Zarya, and on November 20th, 1998, at 6:40 in the morning, these 2 modules connected with each other 400 kilometers above the ground. Thus, the International Space Station was born. Since then, over the past 26 years, engineers from all over the world have collaborated to build their respective modules and sent them into space using rockets to connect with the ISS. Today, apart from the United States and Russia, European and Japanese modules are also connected to the ISS. From the year 2000 until today, not a single day has passed in the 24 years of the ISS's existence where it remained unoccupied. There are astronauts from various countries present inside it all the time. Inside the ISS, all the facilities necessary for astronauts are available, which should be present in any superstructure. Oxygen is the most important, without which a person can survive only for 3 minutes without breathing. Without food, a person can survive for 3 weeks, and without water for 3 days, 400 kilometers above the Earth, where there is neither atmosphere nor oxygen to breathe. Providing fresh oxygen to the ISS is the biggest challenge for astronauts. An average person needs about 15,000 liters or 22 kilograms of oxygen per day. For the 9 astronauts living in the ISS, approximately 200 kilograms of oxygen per day is required. Providing oxygen for so many days is indeed a huge challenge here. Several days' worth of oxygen supply tanks are available in case the system fails. Today, technology has advanced so much that oxygen supply can reach the ISS from Earth in just 6 hours. But this method is only feasible if the rocket launch is successful. It's a good method, but it's very costly because the cost of sending a cargo rocket to the ISS is $200 million. So, sending food and other supplies is sent once every few months. But meeting the daily demand of 200 kilograms of oxygen requires repeated use of rockets, which is quite difficult. Therefore, the ISS, without depending on Earth, produces its own oxygen. It has a small machine that doesn't use anything but water to produce oxygen. When electricity passes through water, it splits into 2 parts, hydrogen and oxygen. Bubbles of hydrogen gas form on the electrode connected to the negative terminal, while bubbles of oxygen gas accumulate on the positive electrode. Now, if this experiment is conducted under normal conditions, these bubbles automatically separate from the water because it's evident that the weight of gas is less than that of water. But in space, where there is no gravity, the weight of gas is almost zero. So, to separate the oxygen gas from water, this machine is rotated, creating centrifugal force, which works like artificial gravity. Due to the rotation, water moves towards the sides, and oxygen gas remains in the middle. The machine then collects it and stores it in containers. Now, you might be wondering, if oxygen is produced from water in the ISS, then where does the water come from in space? Here too, fantastic engineering comes into play in this process. The released hydrogen gas reacts with the carbon dioxide gas exhaled by the astronauts, turning it back into water. Finally, the remaining methane gas is preserved, which is then vented into space. Producing oxygen for the International Space Station is indeed a significant challenge in itself, but an even greater challenge is to preserve this oxygen. If even a small hole were to occur in the space station, the consequences could be catastrophic. In just 1 second, the space station could rupture and disintegrate. But in space, the pressure outside is zero, whereas inside the ISS, the pressure is maintained just like on Titan. If even a small crack were to occur, it would depressurize and rupture. The ISS, which orbits at an altitude of 27,000 kilometers per hour, faces a significant challenge due to space debris. Space debris includes satellite parts and hundreds of small and large meteoroids. The question arises, how does the ISS protect itself from these threats? It's orbiting the Earth at such a high speed that if it were to fly at such a speed close to Earth, it could cross the Pacific Ocean in just 25 minutes. The same Pacific Ocean that takes commercial planes 13 hours to cross. If it were to collide with a meteoroid the size of a grain of sand at this high speed, it would be akin to an impact with an 80-kilogram object. When a vehicle collides with a tree at speed, it can be catastrophic. On March 23, 2012, NASA Mission Control radioed the ISS crew that some space debris was heading straight for the ISS. No one knew how big the debris was until 6 minutes before impact. The entire crew immediately took shelter in the lifeboats. But fortunately, luck was on their side. The space debris passed very close to the ISS without making contact. However, the ISS is not always lucky to avoid meteoroids. To protect against small debris, the ISS hull is made of bulletproof material, similar to the layers found in bulletproof vests. The hull is composed of multiple layers, with the outermost layer being aluminum, followed by a layer of woven material, and then 12 layers of aluminum. Alone doesn't become as strong as it does when it's layered with 2 or more layers. Each layer of bulletproofing helps protect the ISS from the constant bombardment of micrometeoroids, which are as small as grains of sand. These bulletproof layers have been saving the ISS for the past 26 years. But what if a large meteoroid comes in the path of the ISS. Even if it's just 1 inch bigger, the impact at such high speeds would render the ISS's bulletproofing useless. On Earth, mission control at NASA usually predicts the location and position of incoming meteoroids. If one is deemed potentially damaging, the entire ISS has to be moved out of its path using small thrusters attached to the ISS. These thrusters run on rocket fuel, which is scarce on the ISS, primarily reserved for emergencies. To reduce the dependency on rocket fuel, a mechanism has been installed that easily changes the direction of the ISS's 467 kilogram weight. Small boxes are placed at its center, controlled by control moment gyroscopes, CMGs, or gyroscopes as they're commonly known. But how do these boxes change the direction of the ISS, which is as big as a football field? Inside these boxes are flywheels that spin at a rate of 6,600 rounds per minute. Flywheels are heavy, massive wheels that spin rapidly, much like train wheels. When spun at high speeds, they generate angular momentum, which is distributed throughout the ISS's body. Panels are movable. Since the ISS orbits the Earth so quickly, experiencing a sunrise every 90 minutes, and the sun moves rapidly across its position, fixed solar panels wouldn't receive direct sunlight consistently. These panels generate electricity, crucial for the ISS's operations, so it's essential they're positioned optimally. Therefore, the solar panels are movable to track the sun's position accurately, ensuring they continuously receive sunlight and efficiently produce electricity. The panels always orient themselves towards the sun. Maintaining communication with astronauts on the International Space Station posed a significant challenge for mission control. Communication signals through radio waves cannot cross the Earth's horizon, often leaving the ISS out of range. Previously, airplanes were used to catch ISS radio signals and relay them to mission control in Houston. However, this method was costly and unreliable. Often, contact with the ISS would be lost for up to an hour until it returned within the range of mission control after orbiting the Earth. But now, with advancements in technology, the communication issue has been permanently resolved with the help of high Earth orbit satellites. Whenever the ISS needs to communicate with mission control, signals are first caught by satellites, then relayed through the satellite network, and finally transmitted to Houston Mission Control by satellites within range. This way, astronauts aboard the ISS can easily connect with their families with just a few seconds of delay. Scientists worldwide have been striving to make the ISS self-sufficient for the past 26 years. Many innovations have been made, but there are still many requirements that necessitate support from Earth, such as food supplies, water filtration chemicals, spare parts, and cruise ships. The sole purpose is to prepare humans for the challenges they might face when they travel to Mars or deep space. While the ISS is only a 6-hour distance from Earth, when humans go to Mars, there won't be Earth support, nor will the return journey be as easy. I hope you'll like and share this video from Jam TV. Thank you very much for your love-filled comments. See you in the next fantastic video.